Today we will be introducing how to build a robot, how to write a program, and the engineering process. This video is meant to teach high school students, beginners, and those interested in the engineering process. You will learn some basic guidelines on how to solve problems in your own designs. We will be focusing on the main steps in the construction process, which is the focus of building a prototype in the engineering process. We will not be covering the entire engineering process because this is just an introduction. We used the Mindstorm kit to simplify and remove more complicated steps of the engineering process and the construction process. Using a kit increases safety, which is important when learning a new skill. We will use a microcontroller, which is the brain of the robot and controls all of the electrical parts. 2 wheels. Two motors. A slider. We will add 2 motors in a parallel system, as seen in the front. We chose this design for its simplicity and ease to program with. Secure the motors from above so that they will stay in place. Secure the motors from below so that they will maintain stability while they are being powered. Make sure the motors have no vertical or horizontal motion so that they will not lose stability while moving. Add the wheels to the motors. Finish the robot by adding the slider to the rear.
Okay, now it's actually time to make the robot do something. So first we need to open Robot.c, and you need to download it from robotc.net for your operating system. Then on the top left corner, click New File and call it Untitled1, and we'll make this our first program. So to make this program, we have to start with task main, the main function that'll be executed by the robot. Okay, so we use the motor function and we pass the parameter motor A, which is the A port on the RCX, and we set it to equal to 100, which means we give motor A a power of 100. And we do the same for motor C, which this will make the robot go forward at 100 power. And then we say wait 1 MSEC, which is wait 1 millisecond, and we pass the parameter 3000. So this would call those two functions for and make the robot go forward for 3 seconds at both motors going at 100 power level. Let's copy and paste that, and let's change motor A's speed to negative 100. So after it goes forward now, it's going to turn for 3 seconds because motor A is going to go backwards at a negative 100 power level now. And let's comment our code so when we look back at it, we know what we're doing. Okay, so let's copy that piece of coding and copy and paste it 4 times total. So it'll do a little dance 4 times, basically. Well, it'll do each part 1 time, but it'll equal to a whole dance. And after that, let's end the program here. Okay, now we save it, and then we compile and download it now. And that's the next step. So we're done with the coding part.
Now to upload the program that you just created to your robot, the first thing you need to do is connect the included 9-pin serial connector to your computer. Then you want to place a 9-volt battery into the infrared emitter and connect the other end of the serial cable to the IR emitter. Now place your robot facing the IR emitter and make sure it's turned off. Next, we get back on the computer and select the robot menu from the top left-hand corner. Then select Compile and Download. If there are no errors in your code, this will bring up the Download Progress screen. When the progress bar reaches 100% and your robot beeps, you've successfully downloaded your program and can now turn your robot back on.
Next in the robot building process is troubleshooting, looking for any errors in our robot. First, you want to check the wires for good connection to make sure our robot doesn't have any hiccups during the test. Second, you want to check the batteries to make sure the robot is going to have power and nothing's going to stop it from moving. Check the motors to make sure you have smooth movement, and then your robot's complete. And now the moment you all have been waiting for, the testing of the robot. We programmed our robot to do a nice little dance to show you that we have finally completed our robot and that it's functional. And there you go, a completed robot.